Hello everyone, very warm welcome to Venkatvarma Chemistry YouTube channel. I am Venkat Varma, your chemistry host and enthusiast. In this session, we are going to learn about carbonyl compounds, test for carbonyl compounds and Neyman reaction. Let's start our session, test for carbonyl compounds. The test for carbonyl compounds, the first test is the tolerance reagent and failing reagent. Tolerance reagent or failing reagent. What is the tolerance reagent? See, ammonical silver nitrate solution is a tolerance reagent. Ammonical silver nitrate solution is a tolerance reagent. See, tolerance reagent, aldehydes, aliphatic aldehydes and aromatic aldehydes are oxidizing. See, aliphatic aldehydes and aromatic aldehydes not for ketones, ketone does not give this test. Ketones does not give this test. What is the tolerance reagent? Ammonical silver nitrate solution. See, ammonical silver nitrate solution is called tolerance reagent. See, aldehydes, aliphatic aldehydes, aromatic aldehydes gives this test. See, what is the test? See, aldehyde or CHO in tolerance reagent. See, tolerance reagent Ag NH3 to OH. It gives 2 Ag plus RCOO minus NH4 plus H2O and ammonia. So this is a Ag. It is a silver mirror test. With aldehyde with tolerance reagent to give silver mirror test. Yes, it is a precipitation. This is a tolerance reagent. Which of the compounds are give the tolerance reagent? Aliphatic aldehydes and aromatic aldehydes. Oxidizes to give the test. Okay. See, aldehydes with tolerance reagent to give the silver mirror test. Tolerance reagent is a oxidizing agent. Aldehydes reduces tolerance reagent. Both aliphatic aromatic aldehydes give the silver mirror test, but not ketones. Yes. Look at some questions. Which compound reduces tolerance reagent? See, what is the reason behind it reduce the tolerance reagent, which has acidic hydrogen that has reduced. See, acetylene has acidic hydrogen. See, acetylene. So propyne has acidic hydrogen, formaldehyde and formic acid all are give the tolerance reagent to reduce the tolerance reagent. Yes. See, tolerance reagent oxidizes. See, the first one is acetaldehyde, benzaldehyde, acetone and acetic acid. Tolerance reagent oxidizes acetaldehyde and benzaldehyde. Yes. See, look at for example. See, aldehyde. It gives positive test for the tolerance reagent. Yes. Now ketones does not give. It is a negative test. Because ketone does not give the tolerance reagent. Benzaldehyde means aromatic aldehyde. It gives positive test. See, formic acid. Formic acid also give the positive test for the tolerance reagent. Glucose also give the positive test for the tolerance reagent. Fructose. So the fructose, it has alpha hydroxy ketone. It has alpha hydroxy ketone. Alpha hydroxy ketone. Alpha hydroxy ketone. It gives positive test. It gives positive test. Yes, this is about tolerance reagent. Tolerance reagent. Next is a failing test or failing solution. What is failing solution? See, ammonical cuprous chloride solution. See, ammonical cuprous chloride solution is called as failing solution. It is a weak oxidizing agent than tolerance reagent. It is a weak oxidizing agent, weak oxidizing agent than tolerance reagent or tolerance solution. Tolerance solution. Yes, it contains two solutions. So it gives what? Aliphatic aldehydes. Aliphatic aldehydes to give the test. Aliphatic aldehydes. Remember, aliphatic aldehydes. Aliphatic aldehydes or oxidizes. Aliphatic aldehydes only oxidizes. So aromatic aldehydes, see, aromatic aldehydes do not oxidize, do not oxidizes, do not oxidizes. Yes, failing solution A and failing solution B. So what is a failing solution A? See, failing solution, failing solution A. Failing solution A is a aqueous copper sulfate. Aqueous copper sulfate solution is a failing solution A. See, aldehyde with cuprous sulfate or copper sulfate. See, 2Cu2 plus 5OH minus. It gives RCOO minus plus Cu2O plus 3H2O. It is Cu2O. It gives what PPT? A red brown color PPT. It gives a red brown color precipitation is given. Failing solution A with aldehyde, it gives a red brown color precipitation. Yes, let's move on. Failing solution B. See, failing solution B. Failing solution B. What is a failing solution B? It is a Rochelle salt. See, Rochelle salt. Rochelle salt. What is Rochelle salt? Sodium potassium tartarate. See, sodium potassium tartarate. Sodium potassium tartarate. See, what is the formula? It's COONA plus CHOH, CHOH and COOK. It is a sodium potassium tartarate. This is the structure of Rochelle salt. This is about failing solution or failing test. Failing solution or failing test. Let's move on. Next, oxidation of carbonyl compounds. In oxidation of carbonyl compound, the first one is oxidation of aldehyde. See, oxidation of aldehyde or C double bond OH in presence of concentrated HNO3. Presence of concentrated HNO3. Aldehyde in presence of concentrated HNO3 or concentrated concentrated HNO3 and potassium dichromate potassium dichromate or potassium permanganate K2Cr2O7, strong oxidizing agent to give carboxylic acid RCOOH, RCOOH, aldehyde to carboxylic acid with oxidation, aldehyde oxidation to give carboxylic acid. I will look for second one, oxidation of, see, second one, selenium dioxide. Selenium dioxide aldehydes ketones on oxidation with the selenium dioxide to give dicarbonyl compounds. This reaction is possible. The compounds which are having alpha CH2 groups, the condition is the reaction is possible in compounds containing alpha CH2 units. For example, I am writing CH3CHO in presence of selenium dioxide. It gives dicarbonyls. Selenium with H2O. Dicarbonyls are, it means what? Glyaxal. It is a glyaxal. Yes. For example, what is the condition? This reaction is possible in alpha CH2 group. Yes, it has alpha CH2. Group. Possible the oxidation with the selenium dioxide. I'm taking one more example. CH3 C double bond O CH3 with the selenium dioxide. Is it possible? It is possible. Is it possible oxidation with selenium dioxide? Yes. Alpha. It is alpha. Two alphas are present. Yes. What is the product? CH3CO CH3 oxidation. It gives CH3 C double bond with C double bond with H. It gives selenium plus H2O. Yes, this is the product with the selenium dioxide. Yes. Next, oxidation of ketones. See, normal condition, the oxidation is not occur. In drastic condition, the strong oxidizing agents like potassium dichromate, potassium permanganate and concentrated HNO3, it oxidizes. So oxidation of ketones, we are based on Popov's rules. What is Popov's rule? See, oxidation of unsymmetrical ketone. See, oxidation of unsymmetrical ketones. See, oxidation of unsymmetrical ketones. The cleavage of, cleavage means breaking of carbon with the CO. Carbon with CO bond occurs in such a way the final keto group always stay with smaller alkyl group. This is the Popov's rule. See, simply according to this law, the cleavage of carbon CO bond of unsymmetrical ketone always stay the side where the smaller group or smaller alkyl group present. See, what is according to Popov's rule, the cleavage of carbon with the CO bond with unsymmetrical ketones always stay the side where the smaller alkyl groups are present. See, I am taking example. See, CH3 C double bond O CH3. Yes, in presence of KMnO4, potassium dichromating acid medium. What happened? See, cleavage of CO bond. So it is symmetrical, no problem. So it is a cleavage to forming CH3 C double bond OH, and this CH3 is converted to CO2. CO2. I'm taking one more example. One more example. See, CH3, CH3, C double bond O, CH2, CH3, CH3. So, in presence of KMnO4, KMnO4 in H+, what is the product? What is the rule? Cleavage of C and CO bond, C and CO bond, where is smaller alkyl group is present. That is the cleavage. It gives what? CH3, COOH plus CH3, COOH. This is the product. I am taking one more example. See, I am taking one more example. See, C double bond O, CH3, CH3 and CH3, CH3, CH3. What is a possible product? Oxidation with KMnO4 in acidic medium. What is the product? Where cleavages occur? See, is it possible to this cleavage? No. Here cleavage of the CO and C bond. It gives what? CH3, 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 C double bond OH. Yes, it can form what? This part is converted to CO2. This is for oxidation of ketones. Next we can move to Nemold reaction. Nemold reaction, that is a aldol condensation. Aldol condensation. Yes. See, aldol condensation. First of all, what is mean by condensation? What is mean by condensation? Condensation means two molecules are combined together to eliminate the molecule is the condensation. So, aldol condensation means carbonyl compound having at least one alpha hydrogen in presence of diluted base to give beta hydroxyaldehyde when it warms or heated to give alpha beta unsaturated carbonyl compound. See, first of all, what is the condition for aldol or carbonyl compounds having at least one alpha hydrogen? See, condition for having alpha hydrogen. Having alpha hydrogen. What is the next condition to use? What is the reagent used for the aldol condensation? Condensation. What is the reagent? So diluted base like diluted potassium hydroxide, or sodium carbonate, or potassium carbonate, or calcium hydroxide or barium hydroxide, etc. These bases are used for the aldol condensation. First of all, what is the condition for the carbonyl compound having alpha hydrogen? For example, I am taking CH3, C double bond H. This compound has alpha hydrogen. See, unsaturated with adjacent carbon, it is a alpha carbon having the alpha hydrogen. Yes, it has alpha hydrogen. Have a look for this examples. HC double bond H. There is no alpha carbon, there is no alpha hydrogen. Here alpha hydrogen are present, there is no alpha hydrogen. I am taking one more, CH3, C double bond O, CH3. Is it present the alpha hydrogen? So absolute alpha hydrogens are present. Have a look for next example. See, this is the example. See, alpha hydrogen present or not? So here the carbon has double bond, no alpha hydrogen. Yes. Have a look for next example. CH3, CH3. Alpha hydrogens are present. It is alpha position has alpha carbon with hydrogen. It is present alpha hydrogen. Yes. Have a look for one more example. See, alpha hydrogens are present. Alpha carbon is present. There is no alpha hydrogen. No alpha hydrogen. No alpha hydrogen. Without alpha hydrogen does not undergoes aldol condensation. Let's move on. See, beta hydroxyaldehyde. See, It is alpha position. It is beta position. Beta has OH group is a beta hydroxy aldehyde. See what is the actual reaction of the aldol condensation. See aldehydes. 2 moles of aldehydes. 2 moles of aldehyde in presence of diluted base like sodium hydroxide or potassium hydroxide. It gives beta hydroxy aldehyde. It gives beta hydroxy aldehyde. See. Beta, so it is alpha, it is beta hydroxyaldehyde. When it is warm or heated, it gives alpha beta unsaturated carbonyl compound. It is alpha beta unsaturated carbonyl compound. Whether it is aldehyde means aldol, whether it is called ketone is a ketone. Yes. See, I'm writing mechanism, what happened in this mechanism. So 1 mole of aldehyde, acetaldehyde. See, look at for this mechanism, what happened in this mechanism. See, CH3, C double bond OH. Yes, it is a aldehyde. Another aldehyde I am writing like this, HCH2 CHO. Yes. So it is the base, it abstract the proton, it becomes CH2 minus. Yes, this pi bond shifted to oxygen here getting positive charge. So this is negative charge. This negative charge attacks over on this carbon. Yes, this carbon, what happened? See, look at for this. H plus in the form of H plus in the releases. Yes, so this CH2 minus attacks over here. I'm writing C, yes, CH3, yes, CH3, this CH3 and COH, and C. Just wait for this. Beta hydroxyaldehyde is, when it is heated, eliminate the water. Yes, eliminate the water. C to form a CH3. Have a look for mechanism. See what is the mechanism happen in this mechanism. Aldehyde. See aldehyde. I am writing aldehyde HCH2 C double bond OH. Yes, in presence of diluted base OH minus. This base abstract the proton in the form of H plus. It gives CH2 minus C double bond OH. Yes, it is tautomerized. So it forms enolate ion. Yes or no? It forms enolate ion. So CH2 double bond C O minus H. It is a enolate ion. Enolate ion. This carbon ion. Attacks of another aldehyde. See, this is the first step. The second step. See, the CH2 minus C double bond OH attacks over another aldehyde CH3 C double bond H. So this is the CH2 minus C double bond OH. Yes, so positive charge, you are getting positive charge, attacks, it forms CH3 CO minus H and CH plus CH2 C double bond H. This is the second step. When it is heated, what happened? It eliminates the water. See, CH3 OH H and CH2 CHO. Yes, it eliminates the water to form a CH3 CH double bond CHO. It is a crotonaldehyde. It is a alpha beta unsaturated compound. It is a crotonaldehyde. It is a croton aldehyde. This is the mechanism involved in aldehyde condensation. So how to write easily? How to write the easy to write the product? Let's move on. I'm taking one more example. See, have a look for example. See. See. Have a look for this one. Acetone. 2 moles of acetone with diluted base. It gives A, and heated it gives B. So how to write? Very easy to write the product. For example, C double bond O CH3. It is a ketone. Yes. Another ketone I am writing like this. H CH2 C double bond O CH3. So this bond is shifted here. It is in the form of H plus to generate the carbon ion. Yes, generate the carbon ion. This carbon ion attacks this positive charge. This positive charge. It forms, see, it forms CH3OH and CH CH and COCH3 COCH3. See, when it is heated, what happened? So eliminate the water molecule. H2O is eliminated. It gives what? CH3 CH3. Yes, double bond. Yes, double bond CH and COCH3. It is a acetyl oxide. It is a acetyl oxide. It is a acetyl oxide. It is a alpha beta unsaturated carbonyl compound, unsaturated ketone, unsaturated ketone or carbonyl compound. Yes, let's take one more example. Let's take example acetaldehyde, acetone in presence of diluted base. One of the substance is a aldehyde, other one is a ketone. Undergoes aldol condensation in presence of diluted base to give four products. How they are formed? Two products are self-aldol condensation and two products are crossed products. Let's take, I am taking acetaldehyde, 2 moles of acetaldehyde. See, let's write the 2 moles of acetaldehyde, CH3H. Another aldehyde, we can write CH3CHO. Yes, in presence of diluted base. Diluted base means OH minus. See here, to form a carbon ion, the pi bond shifted to oxygen. Here positive charge, negative charge. So H plus is eliminated. So this CH2 minus attacks over an carbocation. So CH3 C H and OH, yes, and CH2 means H2 I am writing like this, okay, and CHO. So when it is heated, eliminate the water molecule minus H2O, it gives CH3 CH double bond CHO. Yes, it is alpha beta unsaturated carbonyl compound or aldehyde. It is a self-aldol product. It is a self-aldol product. Self-aldol. Let's I am taking acetone. C double bond O CH3. So another ketone I am writing like this, CH2 C double bond O CH3. Yes, in presence of diluted base. Diluted base, what happened? To form a carbon ion, H plus remove and pi bond shifted to oxygen positive charge, and this carbon ion attacks over an carbocation. See, like this, CH3. Yes, this can be written as OH and CH. I am writing CH2 and C double bond O CH3. When it is heated, eliminate the water to form a alpha beta unsaturated carbonyl compound. So look at the compound CH3 double bond CH, C double bond CH3. This is the alpha beta unsaturated carbonyl compounds. This is the self-aldol product. It is a self-aldol product. Self-aldol product. Let's take another. See, acetaldehyde and acetone. Acetaldehyde and acetone. See. Another one, acetaldehyde and ketone. See, I am taking acetaldehyde, C double bond O, CH3, H. It is a acetaldehyde. Now ketone I am writing like this, H, CH2, CO, CH3. In presence of diluted base. In presence of diluted base. See, this can form carbanion. The pi bond shifted to oxygen, negative charge. This carbon ion attacks over on carbon in the form of H. It will eliminate the H place. See, I am writing the product. See, CH3, S, H and OH and H and H, CO, CH3. When it heated, eliminate the water molecule. So, what is the product? Alpha beta unsaturated carbonyl compound CH, double bond CH and C double bond O, CH3. It is a crossed product. And I am taking another condition, acetone and acetaldehyde. Look at for the acetone, CH3, CO, CH3. With acetaldehyde, I am writing like this, CH2, CHO. Yes, this can form carbanion, H in the form of H plus. This bond is shifted to oxygen. This carbon ion shifted to carbocation. In presence of diluted base CH3, yes, OH and CH, H and CHO. Yes, when it is heated, eliminate the water molecule. It can form CH3 double bond CHO. It is a alpha beta carbonyl compound. Or aldehyde. This is the cross product. Yes, this reaction is a one is aldehyde, another one is a ketone. It is a crossed aldol condensation. During crossed aldol condensation, to give the four products. Let's take example. Have a look for example. See, pH CHO means benzaldehyde with CH3 CHO acetaldehyde in presence of dilute sodium hydroxide. What are the products? See, in acetaldehyde as alpha hydrogen. Yes, alpha hydrogen. Benzaldehyde has no alpha hydrogen. See, I am writing the product. PH, C double bond O, H. This aldehyde we can write CH2, CHO. So this electrons can form carbanion, H in the form of H plus. This pi bond shifted, here positive, here negative. The carbanion attacked over on the carbocation. See, it forms C, PH, S, OH, H and CH means CH2 and CHO. When it is heated, what happens? Eliminate the water molecule. Dehydration happens. What gives product? pH CH double bond CHO. This is the product. Yes. Now let's take one more example. See, when I'm taking, see how many products are possible. It is a Cross product, yes or no? It is a cross product. One more product is possible, acetaldehyde. See, acetaldehyde, CH3COCH. Yes, one more acetaldehyde we can write like this, yes or no? See, in presence of diluted base to form a carbon ion, H in the form of H plus. This bond is shifted, positive negative charge attacks over here, CH3, CH3, H, yes, and here OH and CH, H and CHO. When it is heated, eliminate the water. Dehydration happen to form a CH3, CH double bond CHO to give two products. Two products. Yes, this is the self condensation product. It is a self condensation product. It is a crossed condensation product. Crossed condensation product. Yes. See, let's move on. One more example. One more examples. Let's I am taking. See, have a look for this example. Cyclopentanone in presence of dilute sodium hydroxide. Dilute sodium hydroxide. What is a product? What is a product? See, let's I am taking cyclopentanone. Yes, it has alpha hydrogen. Yes, alpha hydrogens. Again, this we can write another mole of ketone. We can write like this. See, S. See, eliminate the alpha hydrogen of hydrogen. This can be shifted pi bond, positive negative charge. Yes, in presence of diluted base. Diluted base. What happened? What happened? See, look at for this. Look at for this. See. Yes, you are getting OH, you are getting H. Yes, now when it is heated, dehydrations happen. Dehydrations happen. What can form? This can be formed. See, have a look for this. This can be formed. This is the product. This is the product. Yes, have a see. This is the product. Have a look for next one. Internal aldol condensation. Have a look for internal aldol condensation. See, have a look for internal aldol condensation. Internal aldol condensation, the formation of addition takes place within the same compound. See, it is also in presence of diluted base. Yes, or aqueous H2SO4, aqueous H2CO3, sorry, or Na2CO3, Na2CO3 we can use. See, in this internal aldol condensation, carbon ion formation, see, carbon ion formation means carbon negative charge formation and addition takes place see, addition takes place within the same compound, see, internal aldol condensation, carbon ion formation addition takes place within the same compound. Generally, ring formation takes place in the reaction. The 5-membered, 6-membered rings are more stable. Yes, intramolecular aldol will support 5 to 6-membered ring cyclization. 5 to 6-membered ring cyclization. 6-membered ring cyclization. See, have a look for example. See, it is alpha hydrogen. So, in alpha carbon with alpha hydrogen to generate the carbon ion. Yes or no? To generate the carbon ion. So, this is the first position. 1, 2, 3, 4, 5. See, here getting partial positive charge, here getting partial negative charge. This negative charge shifted to carbon positive charge. Yes, in presence of diluted base. It can form. See, 1, 2, 3, 4, 5. Let's take. See, have a look for. See, it is a first position has C, CO, CH3. It is the first, second, third, fourth, fifth. Fifth position getting OH. this hydrogen can shift it to in the form of H plus to form a OH, in the form of OH. Yes, see here H, when it is heated, eliminate the water to form a, see, it is the internal aldol condensation product. Yes, this is the internal aldol condensation. See. Have a look for Kinijaro reaction. See, what is Kinijaro reaction? Kinijaro reaction is the aldehydes which does not having alpha hydrogen, means no alpha hydrogen, no alpha hydrogen in presence of what is the reagent? Strong base. What is the reagent? Using strong base like sodium hydroxide, See, Cannizzaro reaction, the aldehydes which do not having alpha hydrogen undergoes in presence of strong base oxidation and reduction to give salt of carboxylic acid and alcohol. See, aldehydes, see I am writing aldehydes which do not having alpha hydrogen, to give, sorry, in the presence of strong base like sodium hydroxide to give salt of carboxylic acid and alcohol. See, in this reaction, one of the aldehydes oxidized, while another aldehyde reduced. Yes, let's I'm taking example. For example, C double bond CH2. It has no alpha hydrogen. It can undergoes Cannizzaro reaction. See, CH3 C double bond OH. Here having the alpha carbon and alpha hydrogen. It has alpha hydrogen. Yes, have a look for this example. C double bond H. So here having the alpha hydrogen. So no alpha hydrogen. Yes. C. It undergoes Cannizzaro reaction. Let's take example. See, 2 moles of formaldehyde in presence of strong base or concentrated base, strong base, or potassium hydroxide or sodium hydroxide, or 50% of this potassium hydroxide or sodium hydroxide. It gives salt of carboxylic. One of the aldehyde it converted to salt of carboxylic acid. Another one is converted to alcohol. Yes or no? Let's I'm writing the C double bond O H in presence of oxidation. It gives what? HC double bond OH to form an acid. In presence of KOH means base, it gives HCOOK, salt of potassium carboxylate. Have a look for next HC double bond H in presence of reduction. It gives what? The breaking of pi bond, keeping of hydrogen. Yes, see, keeping of hydrogen. It convert COH to, it is converted to alcohol. One is the oxidation, other one will be reduction. Reduction give the alcohol, oxidation give the salt of carboxylic acid. Reduction give the alcohol. Yes, see, have a look for, see, disproportionation reaction. See, disproportionation reaction. See, if HCHO when it is converted to HCOOK, potassium salt, and it convert HCH to OH. One of the aldehyde is converted to salt of carboxylic acid, COOK. Another one is converted to CH to OH. CHO is converted to COOK and CH to OH. I am taking PHCHO in presence of 50% of the sodium hydroxide. What is the product? Very simple. This CHO, one of the CHO is converted to PHCOONA and one of the converted to PHCH2OH. Yes, see COONA and it is a CH2OH. Let's take another example. CH3 CCHO in presence of same 50% of the sodium hydroxide. This CHO is converted to CH3COONA and again this one is converted to CH3CH2OH. This is the product. Let's take another example. See, CH3 CH3 and CHO in presence of base, diluted base, concentrated base, it gives what? CH3 CH3 COOK plus and CH3 CH3 CH2OH. Yes, these are the products. See, have a look for crossed Cannizzaro reaction. What is crossed Cannizzaro reaction? See, crossed Cannizzaro reaction. Crossed Cannizzaro reaction. Crossed Cannizzaro reaction. See, let's take example. HCHO plus PHCHO. These two aldehydes do not having the alpha hydrogen, so 50% of the potassium hydroxide. What are the products? CHO and CHO. PH here, there hydrogen is there. It is formaldehyde, it is a benzaldehyde. So one of the reactant is formaldehyde, then it will oxidized always. See, oxidized always. See, HCOOK plus PHCH2OH. Yes or no? So write one of the reactant is formaldehyde. One of the reactant is formaldehyde. Then it will oxidizes always. Yes. See, let's take one more example. See, HCHO plus CH3 and CHO. What are the product? Let's take 50% of the potassium hydroxide. So obviously what happened? So this formaldehyde is converted to HCOONA. It is oxidizes. The another aldehyde is converted to alcohol, CH2OH. This is for the crossed Cannizzaro reaction. Have a look for intramolecular Cannizzaro reaction. See, intramolecular Cannizzaro reaction. Let's see HO and CHO in presence of 50% of the sodium hydroxide. See, concentrated sodium hydroxide. It converts COONA. It is converted to salt of carboxylic acid and alcohol, CH2OH. One is oxidized, other one is reduced. Yes, other one is reduced. I am taking one question. So benzene with CHO and CHO. See, in presence of 50% of the sodium hydroxide, what happened? It happened, see, COONA and CH2OH. These are the products. Have a look for this question. Have a look for this question. See, benzene with the CHO and CH3 in presence of concentrated potassium hydroxide. What happened? So in this substance do not undergoes Cannizzaro reaction. What is the reason behind it? Are the disubstituted aldehyde? See, are the disubstituted aldehyde do not involve Cannizzaro reaction. Cannizzaro reaction. Yes. See. See. Next is a haloform reaction. Haloform reaction. See, what is haloform reaction? Haloform means chloroform, bromoform, iodoform. See, chloroform. What is a chloroform? CHCl3. What is a bromoform? CHBr3. What is the iodoform? CHI3. So, which type of substances to give the haloform reaction? See, methyl ketones or C double bond O CH3. It is a methyl ketones and secondary alcohol CH3OH. It is a secondary alcohol and ethanol CH3CH2OH ethanol and beta methyl alcohols to give haloform test or haloform reaction. What is haloform reaction? See, generally methyl ketones in presence of bromine in sodium hydroxide to give bromoform is a haloform reaction in presence of X2 with KOH Br2 in NaOH. Let's take an example. See, have a look for example. R C double bond O CH3. It is a methyl ketone in presence of X2 with KOH. It forms RCOOK plus CHX3. It is a haloform. Yes, it is a haloform. See, first what happened? Halogenation. See, halogenation is happened. First is a halogenation. Look at for the reaction halogenation. The first step is the halogenation. Let's say I am taking R C double bond O CH3 H and H with halogen. Halogen means X. See, X and X. See, it forms. See, look at for this to form a RC double bond O X3 CO X3. So this is halogenation. What is the next step? Next step is a hydrolysis. Have a look for the reaction. R C double bond O CH3 in presence of KOH. Here breaking the CH3, keeping the hydrogen. Yes. Here breaking the CO, keeping the OK. Yes. To form a RCOOK plus CHX3 haloform. This is the haloform test. Yes. This is the haloform reaction. See, have a look for example. See, CH3 yes, and a CHOH with H. It is a ethanol in presence of X2 with KOH. What happened in this reaction? First undergoes oxidation. It is converted to ketones, methyl ketone. It is converted to methyl ketone. How to convert? So oxidation insertion of the oxygen. See, insertion of the oxygen. See, oxygen insertion, it form CH3, COH, OH and H. Yes, one carbon with two OH, it is unstable, it is converted to CH3, C double bond H, S minus H2O, minus H2O. When hydrolysis and halogenation and hydrolysis, what happened in presence of halogenation? It convert CH double bond CX3. Again, it is treated with the potassium hydroxide. It convert HCOOK plus CHX3. CHX3. This is a haloform reaction. Haloform reaction. See. Have a look for some question. Which of the following gives haloform test? Haloform test. See, it is acetaldehyde, it is acetone, it is CH3COCH2, it has a methyl ketone and ethanol. Ethanol. So it gives haloform test. It is also gives. The option is all. All are giving the haloform test or haloform reaction. Have a look for next question. Which of the following do not give haloform test? Do not give haloform. It is CH3CO, methyl ketone, CH3CO, CH3CO. So CH2CO, CH2, CH3. So it does not use. It does not use the haloform test or haloform reaction. Yes. I hope like this video. Don't forget to share your friends. Don't forget to give like. If you find content is valuable, make sure to subscribe to stay updated, latest update. Thanks for watching.